So good day, everyone. So we are now in our week 4 to 6. So it's all about physical factors of the environment and its sampling methods. So from this topic, we will be talking about meteorological factors, air quality, water quality, and soil quality. So let me just share my screen to you, and I will just turn off my video so I won't be conscious enough to explain to you these topics. No? So for the flow of my presentation, I will be talking about first two topics, which is about meteorological factors and air quality. So for meteorological factors, we have solar radiation, temperature, water, rainfall, evaporation, and humidity. And for the air quality, we'll be talking about atmospheric gases and particles, and of course, the air pollution. So different pollutants that are present in the air. So there are two perspectives in studying the physical environment. First is that the physical environment is indispensable to all living organisms. So when we say indispensable, no, we are talking about so when we say indispensable, we are talking about the essentiality of the physical environment to all organisms. So if we can recall the basic knowledge about ecology, it's between the interaction of organisms in the environment or the physical environment in specific. So if, for example, humans, and plants cannot live without the basic necessities such as water, sunlight, no? Those are just factors, for the physical environment that we rely upon. Second is that the physical environment is gravely threatened by anthropogenic activities. So when we say anthropogenic, it means it is man-made activities. So those activities na kita ang gabuhat, like creating pollution, like water pollution, there's no such thing as existing pollution in this world, but the humanity has created that pollution, in this world. So we are creating our own pollution. So that it is what we call anthropogenic activities. So for example, we have solid waste in the river. So we are making that. Those are anthropogenic activity. We are contributing to the waste of the river by throwing garbage anywhere, by not properly disposing it, or by not separating biodegradable from non-biodegradable. Aside from that, those activities like industries, industries are emitting pollutants, air pollutants in the air, so which makes it or which emits pollution, to the air itself. So those are just perspective in studying the physical environment, so that we know the quality of the standard of our lives, as of the moment. Kay kung mo samot na ni siya kataas ang emission, samot na ang levels of contamination, then maybe there will be a great effect. If you can remember India, nga naa sila parts sa India wherein very grabe na ang smog, because smog is a combination of fog and then smoke, in which nga na-trap siya sa ubos sa atmosphere. So wala ang emission bitaw kay wala na siya wala na siya na dispense sa larger na what do you call this environment. So nag-stock up na siya dito. That's when feeling nilang tugnaw siya, pero smog di ay ito, combination of smoke and fog. So ang nahitabo is very polluted na dito siya nga area dito ng air nila. So let's now talk about meteorological factors. So we have the solar radiation or energy. So basically, sun provides the earth energy, and most of our living things rely upon the earth's energy, such as the plants. No, they can't live without solar energy or sunlight. It's because it's where they manufacture their own food. So another one is sun hastens photosynthesis, which allow plants to manufacture food. That's it. And then the sun emits energy in the form of electromagnetic radiation. So basically, if we try to let's say go under the heat of the sun, no, we can feel that naatay init kayo because of course it transfers electromagnetic radiation towards us nga makapil taog ka ng kainit, no? It's the radiation, no, that is emitting coming from the sun, no? Emission coming from the sun. Another is the solar energy creates the movement of air in the atmosphere, generating climate and weather changes and affecting the circulation of waters in the ocean. So sometimes the solar energy may help re-radiate, no, the solar energy outside the earth. Pero since medyo daga naman kaayo ta og gases in the atmosphere which lessen the kaning capability of the solar energy to re-radiate back outside the earth. So mahitabo is matrap siya. So since this emissions, this gas pollutants such as the carbon, excess carbon in the atmosphere, our ozone layer has now been depleted, or maybe nagkagamay, nagka-thin na siya, nagka-thin. So the layers of our ozone layer, na nagka-thin na, so that's the time nga ang sun dayon imbis na mo re-radiate siya back the earth na as much as it is being absorbed inside the earth, ang mahitabo is it's not equal, no longer equal. It's because mas daghan na ang musulod mo absorb sa earth kaysa mo gawa sa earth. So that is because of the emission of excess carbon or other pollutants in the atmosphere, which traps the solar energy or solar radiation, re-radiate back to outside the earth. So mao na siya nga we experience global we experience climate change, so global warming could lead to climate change. That's why we have experienced a lot of disasters, not dili na siya the same before. Like we lot of countries na experiences na dili usually gina-experience nila sa una. So I'm sorry for my background now since I recorded this sa classroom and then ay mga gaaging asakyanan sa engineering complex. So I hope that you bear with my presentation. So for the principles of solar energy is radiant light and heat from the sun that is harnessed using a range of ever-evolving technologies. We have the electromagnetic radiation, for example. And an important source of renewable energy which captures and distributes solar energy and convert it into solar power. So technology nowadays have already evolved in which that we reuse the solar energy that has given us. So we convert it into source of electricity, for example, for the solar panels. So a lot of industries and even at homes, there are people who are using nowadays solar panels, no, to of course save the earth, and at the same time lessen their consumption in terms of electricity bill. So aside from the energy used for cooling, heating, drying, distillation, power generations are also the main source. Their main source are the solar energy. So another source for solar energy, we have heating of water, heating of houses, distillation of water, cooking food. So most of the time we use solar energy. No, even maglaba lang ta tapos ihalay nato para maugat to siya, we need the source of sunlight. So basically, it's very important. No, it's a basic necessity of life. So let's now move on to terrestrial region of Earth. So as you can see, we have different biogeochemical cycle. If you can still remember your ecology, no, that we already maybe your teacher or your instructor have already told us what this biogeochemical cycle is all about. So basically, no, in terrestrial radiation, this is what we call the energy in which the energy is released by the earth itself as opposed to solar radiation, no, that it receives from the sun. So basically, kung naay solar radiation, naputi ginatawag na terrestrial radiation, which is coming from the biogeochemical cycle in which nga ilahang excess heat is of course released towards the terrestrial, no, or the land areas, no, which is also one of the components in this cycle. So apart from the energy generated by the decay of radioactive minerals in the rock, for example, the energy that drives terrestrial radiation ultimately comes from the sun. So this is, of course, a major factor in the study of global warming, in which na kaning mga biogeochemical cycle, these are just cycle in which na naay part ani are also involved, no? Naay part ani, I mean, naay part ang humans and even other organisms na they take part for it, no, to of course to happen this kind of cycle. Like for example, carbon cycle. Basically, we have existing carbon in our atmosphere, but since due to a kuan kanang increasing population, we tend to emit more carbon, no, in the atmosphere. If you can still remember, no, about carbon footprint, that we release carbon if we are first, kung traveler ta, that means more carbon emission, ay more carbon footprint, no, ang gakuan sa atua, ang naa sa ang measurement, mas taas ang measurement sa carbon footprint. Kung gapalitan ukay-ukay, no, mas taas ang carbon footprint. It's because that kaning kung mag-travel ka, fossil fuels are used in airplanes. So that means it emits a lot of carbon. So kung makatravel ka in a year, like twice, thrice, or even 10 times, no, the more carbon ang imong gina-emit sa environment. So kaning carbon footprint is measured individually in humans. So basically, kung ikaw traveler ka, whether via sea, via land, no, they use fossil fuels. So more carbon emission ang ginapagawas nimo as individual. Aside from that, no, we also have carbon, like even let's say we are meat eaters, no? We are meat eaters, so that means no, we are also emitting a lot of carbon, no, outside. It's because these organisms no eat, let's say igno na to nga, they eat plants, and plants absorb carbon because they are very known to be a carbon sequester, no? So ang mahitabo is kung inaning i-take up na carbon, this will be now present to the organisms, higher organisms. So the more pod ka nga kung ginakaon nimo ni sila, the more pod nga dako ang imong carbon nga in or dako imong carbon nga gina-emit, no, as an individual. So that's it, no. That's why we relate that to global warming, because global warming, no, is, if we can recall, it's the excess, no, of kanabitang gases, no, which makes our world, or which makes the earth warms, and when it warms, it would lead to climate change, no. So the word global warming is different from climate change. We can say it's climate change if naano siya yung mga existing na phenomena nga gakahitabo, no, out from global warming. So kung ato siyang ikuan, no, i-rank nato, climate change is the biggest part nga kasi gakahitabo sa ato ana what is happening now, and global warming is just a kuan lang, a step below than climate change. Okay, so now let's move on to method of measurement. So re-radiation of Earth occurs as long-wave radiation, which measures 5 and 10 microns, while the short-wave radiation measures 0.2 and 0.5 microns. So what are these wave radiations? So basically, this long and short wave radiation is emitted by the Earth. Now, these are what we call terrestrial radiation, in which na kung unsa to ang irradiate coming from the sun, it will receive in the terrestrial ecosystem. So mo nang receive sa terrestrial ecosystem, and that's what we call terrestrial radiation. Kung ihanap po ni ibalik, no, going sa mga organisms nga present dira sa kanang terrestrial, no, so terrestrial area. So this long wave radiation is basically it's just it just plays a small part in the radiation balance. For example, in a day, no, nga muna ni siya balancing, mura ni siya ang what do you call this, gaka experience nga kanang kainit. But when we say short wave radiation, which measures 0.2 and 0.5 microns, these are what we call as the solar radiation. Okay? If ang shortwave radiation, no, kay mas daghan siya o kanabitaw, kung daghan taga ka-receive na shortwave radiation, it can actually kill us. So that's why shortwave rang ato ang gaka-receive here on Earth. It's because na ay tendency nga wala na life ang present if kung mostly shortwave ang present sa environment. Okay, kaning mga long wave radiation, these are just waves that balance our ecosystem. Nga although mainitan ta, pero makaya ra nato ang kainit compared with the shortwave radiation, in which na ay part sa areas labi na tong mga high elevation. Although katong mga high elevation, no, has increasing temperature during night, but decreasing temperature during night, but mostly sila ang gaka-receive una sa pinakataas nga temperature during the day. So that's it. So there are types of radiation, no? We have the direct radiation. So it is also known as shortwave radiation. So muna akong giingon ganina na direct radiation nga. Although maka-feel tag heat, but dili siya inana kakusog dapat nga atong ma-receive supposedly. Kay it will kill humans, no? Not even humans, but also other organisms such as animals, no? And even plants. So solar radiation that reaches to the surface of Earth without being diffused is called direct beam radiation. So in order for this to be measured, the direct radiation is through a per heliometer, which composed of receivers wherein the upper sensitive surface is blackened, no, to absorb a high proportion of solar radiation. So mostly, kung magamit tag ani, di ba usually masila magita sa init. So ang iyang gabuhatan ani is i-blacken niya, no, ang kuan surface or maybe the color. We don't know the term, but kato dayon i-absorb din to niya to know the proportion of the solar radiation that is being or that is being radiated, no, towards towards areas, no. So mo ni siya. Another type of radiation we have is the total sky and sun radiation. So it consists of short wave and long wave radiation. So this is a combination of short and long wave radiation. Now this is the sum of diffuse and direct solar radiation, which is also called as the global solar radiation. So the global radiation, no, is measured with pyranometers, and the direct radiation nga tong gina-term ganina is the per heliometer katong ganina, no, previous slide. So the device used two types of sensors, no, the thermal and the photovoltaic. So kani siyang pyranometers is or are sensors that convert the global radiation, the global solar radiation it receives into an electrical signal that can be measured. So, kani siya, ginabutang ni siya specific areas in which nga this should be exposed all year round and all kinds of weather, whether mag-ulan, magbagyo, so dapat naara ni siya dito. So, they must be robust, stable, and resistant to corrosive effects of damp air. So, okay, since this is this is exposed all year round, so which means dapat dili ni siya dali mataya or something like that, no. So another way of how we measure solar radiation is through temperature. So yes, no. This is a relative measure of hotness or coldness. This is temperature, and it is measured using a mercury thermometer. So usually mercury thermometer are, I don't know if it's banned. So I think it's banned nowadays because of the mercury content, no, na naadari sa iyahang tip. So I'll just show my laser pointer. So this one. So aside from that, the variability of temperature is extremely important to ecology because there are certain organisms that can only be or that can only tolerate specific measurement of temperature. So most of the time, most of the organisms, no, are very sensitive to changes of temperature, no. So another is that the water, no, which is a substance composed of chemical elements like hydrogen and oxygen and existing in gaseous, liquid, and even in solid states. So this is basically a physiological necessity for all organisms. We all know that. Okay, even us needs water, no? Rainfall, humidity, evaporation, and the available surface water supply are the principal factors measured. So let us first discuss rainfall. No? Oh no. Okay, so rainfall is a form of precipitation, meaning it is a weather phenomenon characterized by the return of water from the sky to the ground. So basically, you know the water cycle already, no? Katong evaporation, condensation, and then precipitation. No, so mostly this is measured by rain gauge. This is what we call rain gauge. So there are different types of rain gauge we have. So na glass nga murag mo measure lang siya pag mapuno na siya. We also have this type of which is also present in our laboratory kaning inani no, but we still don't know how to set this up. So natay in ani. So the average annual rainfall in the Philippines is 2,000 millimeters. So we are receiving every year 2,000 millimeters of water. So it depends on specific months siguro kay mostly naman ginay mag-ulan ng mga months sa ato during June, July, mostly rainy season na sa atua. So, however, the amount of rainfall depends on location and time. So, this is what we or what you have encountered, no, mga terms that you have already encountered in your previous nga mga lecture, in which nga climate is different than weather. Climate is different. Weather and climate is not the same. So, inana na siya, no? So, moto nga, na-define na to sa inyo ha, nga, weather is, of course, differs in a specific location. So, katong ginaingon sa inyo ha, nga, dili pasabot nga nag-ulan dari sa Gusa, nag-ulan sa Tanan, Cagayan de Oro City. So, mo na siya ang weather. Has kanang different, no, different in terms of their kanang sa locality. So nag-ulan dari sa Gusa, maybe wala nag-ulan sa Bulwa, no? So that's weather. For climate, of course, here in the Philippines we encounter hot and dry seasons. So we don't experience snow, winter, no, or winter, autumn, spring. So those are climates, what we call climates. So another is evaporation. So it's a form of water loss that naturally occurs in surfaces such as open water, bare soil, or vegetative cover. So it is measured, of course, by atmometer and evaporation fan. So before that, now, evaporation is a natural mechanism which dissipates the heat content of the surface where evaporation occurs. So for every gram of water that evaporates, now there is 540 calories of heat is lost. So which means nga, sa pasabot ana, nga kung for example mag-evaporate ang isa ka gramo sa tubig nga mag-evaporate, no, makawala siya og 540 calories na heat. So the instrument used for that is the evaporation fan and atmometer. Sometimes I've read other journals, no, that if they don't have this type of measurement for evaporation, no, they use basins, but maybe it's not that let's say it's not that reliable. It's because nani siya mga sensors maybe, or something like naa siya makaya mga measurement nga super detailed, in which nga need po siya sa evaporation ng nga measurement. So an atmometer or evaporimeter is a scientific instrument used for measuring the rate of water evaporation from a wet surface to the atmosphere. So kung mag-ulan, pila ang sa isa ka day pagkaugma, i-measure nimo ang evaporation by looking on the specific meters nga gigamit nimo in which nga tanawan nimo ang mawala nga tubig. So, usually no kaning mga atmometers, they are mainly used by the farmers and growers no to measure evapotranspiration in their areas. So, una siya nga usually gina-set up ni siya at the different crops location and even any field location. So, ginagamit na ni siya nowadays. So, we also have humidity. When we say humidity, it's unsa kaalimuot ang imuhang measure na siya sa kaalimuot sa imuhang na feel. So, the higher the humidity, no, unsa man na siya pasabot, it means na kung 100% ng humidity, it means that it's raining, already raining. So, muna siya nga alimuot ang inyong ma-feel. So, it represents the amount of water vapor in the air. And we have the relative humidity, which is the percentage of vapor actually present compared with the saturation under existing temperature pressure condition. So it has actually has vertical and horizontal difference in which that we measure it through the psychrometer. So I think you all know what psychrometer is. So you had this in your Quran ecology. You even use this and even break this, no? Inyo na ni siyang naguba. So for psychrometer, we have the wet, this one having a damp cloth, and we have the dry bulb. No, so I know that you know how to measure relative humidity through the use of psychrometer. So that's for solar radiation, no, mga different types of how you measure it, no. So those are just for meteorological, not only for solar radiation, but for meteorological factors, no, that we need to consider. So now let's move on to air quality. So for air quality, it's a measure of how clean or polluted the air is. So monitoring the air quality is important because polluted air can be bad for our health and the health of the environment. So air quality is measured with the air quality index or AQI, and the AQI works sort of like a thermometer that runs from 0 to 500 degrees. So basically in the air quality of the Philippines, we have a standard, no, that we are using. It's coming from the DNR, no, the Department of Environment and Natural Resources. So, however, no, instead of showing changes in the temperature, no, the AQI is a way of showing changes in the amount of pollution in the air. So, dili lang ang AQI is not just a measurement of the changes in temperature na init kaayo ang air, medyo alimuot, no? But it also shows the changes of the amount of pollution in the air. So, dani may balaan nato kung sa polluted ang ato ang air. So, that's it. No? So, let's now move on to atmospheric gases. So, the atmosphere or the air around the earth is a great natural resource. And of course, the movement of air, local winds, or weather fronts across the earth's surface continually renews the air around us. And it is strongly influenced by sunlight and by compounds produced by light. So let me just show you a table in which this is the so-called dry air or dry atmosphere which contains no water vapor. So if you can see the table, no, this is a table in which the sea level atmospheric composition of dry air. adapted from Black and Griffiths, you can see that we have the following gases no available in our in the atmosphere, and of course, yes, in the atmosphere. And usually they contribute this measurement no in the level of our in the composition of dry air. So if we relate this no plants basically it release oxygen no, and this oxygen no is just a waste product of the plants no nga ilang ipagawas, and it will eventually what it will eventually contribute to the existing gases in the atmosphere. So mo na siya nga naatay ginatawag na exchanging of gases. If the plants gives off their waste products, which is the oxygen, we also give off our waste products, which we call carbon dioxide, to them to help them no process photosynthesis. Now, so that's it. So let's now move on to air pollution. No, aside from the listed substances sa table nga nakasulat dito on the previous slide, the atmosphere is also composed of other substances such as oxides of sulfur, if you can still recall that, no? Oxides of nitrogen. And then we also have carbon monoxides, which can be seen in the vehicles, no, which they emit it every day, every hour, every second. And we also have the ozone, and of course the hydrocarbon and other particulate matters, no. The particulate matters are what we call particles, no, particles of which their size is equal to or less than 10 microns. Mo na siya natawag ito mga PM 2.5, PM 5, PM 10, no? Those are particulate matters. So, so air pollution is the introduction of chemicals, particulate matter, or biological materials that cause harm or discomfort to humans or other living organisms or damages the natural environment into the atmosphere. So now, what really is no the sa kining asa gid na sila nagikan? What really are the sources of this air pollution we have? So basically, if we look at this whole figure, we can see that the main sources of these air pollutants are the emissions coming from the anthropogenic and biogenic. So for anthropogenic, no, these are what we call coming from the point area or mobile. So for the point area, basically, ang point, we have the sources na not point and non-point sources. So the point sources are what we call directly, kung asa naggikan yun, originally sa ilaha. Those are what we call point sources. So let's say ignan nato nga kaning mga sources like kaning mga industries nga nag-manufacture of maybe mga coal power plants no nga directly og emit sa ilahang aso kada gabi nga dili na to makita nga dili makita sa DNR. That's the time na ilahang ginapagawas na sa ilahang industries. So those are point dito gyud gikan sa ilaha ang emission or ang pollutants, no? Mobile, coming from, of course, automobiles nato, nga coming from the cars, from the big vehicles, especially those vehicles that are not or that are greater than 5 years, no? Older than 5 years na mga vehicles. So those are contributing to air quality. So another is emission coming from the biogenic sources. When you say biogenic, it's coming from the living organisms. So basically, kani mga living organisms na katong giingon sa inyo, like for example, carbon, we humans no gives off carbon just by traveling, just by eating meat, just by kuan kana sa tawag ani kining magkuan og ukay-ukay, because ang ukay-ukay is being brought here by different countries in which nga gamit sila via sea, via air, oh, 'di ba ana? So which means they use fossil fuels to reach to the Philippines, and that's why there are emissions causing no, or there are emissions to such actions, no. So the atmospheric processes, no, has given or used these emissions through transport like wind, the clouds, no, or even transformation. Maybe it was now being uh, processed, no, from in chemistry. These gases are now being exacerbated with kuan kanibitang other gases. So mura sila og since na kuan na sila, mura sila og ang ilang composition, no, mas ni mura sila nag-evolve or something like that. They transform into another type of uh, from the element, nag-combine na sila, no? So inana. And even wet and dry deposition. So it will now lead to the receptors, which are the air concentration. So what is in the air concentration right now? Is it less ang iyang pollutants or taas iyang pollutants? So basically, or maybe it would also lead to deposition or loading. So maybe nara siya sa atmosphere, kay let's say other gases no would take 300 years para ni siyang mawala sa atmosphere. And if it will take that long, so every day, every hour, we emit such gases in the atmosphere. So magbulat na pug another 300 days, so murag nagtambak na sila dito niya ang uban kay wala pa gani na abot og 300 days na napoy nadungag every day. So if you can imagine, no, nga how these gases are being trapped in the atmosphere for so long, and that we experience a lot of disasters nga atong gaka-experience today, in which the effect of this so-called trapped gases, no. So muna sila. So the sources of air pollution is the first way, and in way of second way, no, in a way or in what the so-called second way. So kaning mga first way is what we call natural ng mga activity, like for example volcano activity, nga kung mubuto siya, usually it will give off sulfur to the atmosphere. So mona siya, no, nga there are those people living nearby the proximity or close proximity to the volcano, no, ang may tabo sa ilaha, they will of course inhale the ash, and it will give, or it will have a potential danger to their health. And even sandstorm, no, sandstorm, this is of course natural, in which they are present usually in some areas, those having sand, no, sands. So muna siya naturally occurring na sila. And then The second way is, of course, the total sources, which is either stationary or mobile. For stationary, we have the point sources or the area sources. So the point sources are those uh, katokong istorya ganina no, of which I've mentioned, industrial processing, in which the mga power plants, even the volcano, these are point sources. These sources comes from originally from them. We have also their area sources. So for example, uh, kanisha, domestic heating of coal and gas, no? Nga kani sila, kani nga area, nagbuhat sila ginani, dito na po sa area, na po isang, nagbuhat ana, and so on and so forth. Na may tabo nga, murag, kuan na siya, what do you call this? Naglump na, or nagsagul-sagul na, no? Isa ni siya na murag na consolidate na tanan ang kuan ang kaninga mga pollutants. And we also have the on-site incineration, which is, I think, ginaban na ni siya. Incineration, which means ang pagsunog-sunog, no, sugnod-sugnod. Even other barangays, no, are doing or implementing ordinances in which that bawal na magsugnod-sugnod sa balay. Even na mura na siya o kanang fogging for para makawala ang dengue, bawal. Even kuan kaning leaves, bawal na siya sugnodon karon. So there are ordinances that implement, no, in every barangay, that is being implemented in the barangay about that, no. And another sources, no, we have the mobile, which comes from the line sources, and the area sources. So coming from the line sources, kaning mga highway vehicles and railways. So basically, it's a public nga kuan, ng agianan. So those are, kana sila mga kuan, nag-contribute og mga air pollutants, no? Aside from that, the area sources, no? Maybe sa kanang mga kung naay airport na sa Cagayan, airport po padulong sa Palawan, sa Manila, no? Contributing factors, no? Kaya of course, isa na itong atmosphere. Earth's atmosphere is only one for all. So, bahalag, dili man nato ginaingon, ginalimit na ang climate change is only present in the Philippines, not in other countries, because they are doing sustainable development ng mga strategies. No, we can't say that. Everyone is affected with climate change because we only have one biosphere, which is the Earth. No, isa ra kabuk ato ang gilive in, no, ato ang place na gilive in, which is the planet Earth. So we are all experiencing climate change, not only in the countries such as US, such as Antarctica. No, it's overall the effect of what we are contributing today. So mao na siya. So these are examples, no? Industrial emission, burning of fossil fuels, mining operations could also give pollutants, no, to the air, gives off pollutants to the air. So the classification of air pollutants now, we have the primary and the secondary air pollutants. So kaning mga primary air pollutants, these are emitted directly to the atmosphere. So there are 5 primary pollutants that contribute to the 90% of global air pollution, and that's the oxides of carbon, like carbon monoxide and the carbon dioxide, the oxides of nitrogen, like NO, NO2, NO3, or expressed as generally termed as NOx. The oxides of sulfur, particularly sulfur dioxide, no? The volatile organic compounds, mostly hydrocarbons, and of course the suspended particle matter, or the SPM. Examples are the aerosols. So those are primary pollutants, no, to the global air pollution. So now, let's now move on to secondary air pollutants. So basically, secondary air pollutants are the pollutants that are produced in the atmosphere when certain chemical reactions take place among the primary pollutants. So katong mga carbon dioxide, katong mga carbon monoxide, carbon dioxide, so kung naa sila'y kaning mga naa na sila'y sani kaning chemical reaction nga mahitabo na ni specific na mga secondary pollutants ang present. So these are what we call secondary air pollutants. So the sulfuric acid, nitric acid, carbonic acid, ozone, formaldehydes, and even peroxyacyl nitrate or the PAN. So, okay. So let's move on to the air pollutants and sources. So as you can see, no, kani sila, na these are the major contributing pollutants to the air. Carbon monoxide, which is of course produced by the incomplete burning of carbon containing fuels such as petrol, coal, and wood. No, even the sulfur dioxide, which produced by burning of fossil fuels such as the fuel oil and coal. No, so kani sila ang mga kuan ani ang the main source ani kay produced by those kuan kaning power stations and even metal smelters. And the nitrogen oxides, which are produced by petrol or diesel burning engines and coal or oil furnaces. Even the ozone, no, is produced by the reaction of oxygen gas with free atoms of oxygen, which are formed from the reactions between nitrogen oxides and hydrocarbons in the sunlight. So another is the particulates, which produced by refuse incineration factories, diesel vehicles, construction sites, and coal and or charcoal burners. So usually kani sila no in one setup or one let's say source, like for example industrial mga kuan sources like coal or coal power plants, no, it can give off a lot of air pollutants, not just sulfur dioxide, but also particulates, no? So, kind of mga nitrogen oxides. So, those are contributing to a lot of emission in the atmosphere. So, even hydrocarbons, no, formed from the evaporation of materials such as petrol, diesel, and solvents when exposed to air. So, muna siya nga, ang kaning mga oil, even crude oil, maybe, if once they are exposed to the air, they will now become hydrocarbons. So hydrocarbons are present usually in kaning mga gasoline stations. So kana sila. So how to sampling and measure gases? So I'm just telling this, no, I'm just giving you an information. Just maybe you would want to deal with either meteorological mga factors or maybe in the air quality. You can use this in your methods sa inyong thesis. So that's why I'm giving you an idea on how to sampling this type of gases, no. So depends po no kung asa nga areas. So that's it. So source and ambient sampling. Source and ambient sampling. Yes, there are two sampling equipment we have. We have the source sampling equipment, which consists of probes that are inserted into a stack or vent and collection equipment. So we don't have this type of equipment or facility in our school, like USTP. This is much complicated, which measures the ambient air, no? So the process of using this is the samples are withdrawn and analyzed immediately or contained for later analysis. So maybe in a way that imuha ni siyang exposed outside, outdoor, and then you'll measure by, of course, nana siya sensor. Measuring it would also give immediate analysis, or maybe you would want to expose this for a period of time, maybe 1 hour a day or or maybe in a week, 3 times a week, or maybe depending on your method or method that you used in your study. So kana siya. We also have the ambient air sampling, ambient sampling equipment, which is of course present in your laboratory. So you can use this. You can ask Sir Ken, no, to teach you on how to use this type of air, or maybe you already use this in your air quality, air pollution. I don't know. So it consists of a suction pump and a collection medium. So these are protected, no? So kanisha usually, we have not tried this. We can expose this outdoor, but butangan siya og kaning mga shelter nga kanang dili siya mabasa kay wala ta kabalukon sa effect niya, so maguba dagan mahal ba kining mga inani, no? So ang iyang process is it takes up or it absorbs pollutants and na siya filter sa sulod, in which it captures maybe particulate matters such as PM 2.5, PM 5, and PM 10. No, and then kung mapuno na ang filter, that's how you would actually measure. It would undergo gravimetric method na inwa siyang constant weighing, and then you will be taught with your water air pollution na. So this is just my experience on the gravimetric method nga imo siyang i-measure, no? Then imo na pud siyang ikuan until ma-measure nimo ang or ma-measure nimo tong constant weight niya. So inana siya. So that's it. So kanisha, these are protected from elements, no, and form of vandalism and other often are designed to run unattended for long periods of time. So you can use this outdoor, but make sure that it will be protected nga dili siya mabasa. Okay, it would it is only run by maybe kaning battery, or pwede po niya siya sa atua. It can this is rechargeable sa atua. So, kailangan ahead of time kung magamit mo ani dili basta-basta diretso-diretso. So, kailangan pa siya i-recharge before using. Maybe kung labi na ko yung sampling is 24 hours a day. So, it was even used, no? Na-use na siya for 24 hours a day. So, for measuring gases, no, samples that are collected by ambient or source samplers are analyzed because it may contain numerous chemicals that can be toxic to the environment at very low concentration. So, if you can still recall your DNR, ng mga DAO, no, ng mga DAO, katong administrative, what do you call this, Department of Environment and Natural Resources Administrative Order. So, na yung mga order dito, katong DAO 34 is for water, DAO 35 is for wastewater, and I forgot for the air. What DAO was that, if you can still recall. So, for measuring gases, no, we can measure gases through gas chromatography or mass spectrometry. So I remember nung ganini mo makita or ma-measure kung naa ba present ang sulfur or SOx, NOx, kana sila katong sulfur oxides of nitrogen. So it will be measured through gas chromatography and or mass spectrometry. So this is just an example of real-time air quality index, no, in the Philippines. So this is recent ni siya, no, nga result, in which nga this green one, yellow-green is the yellow-green colored is interpreted as good. So usually the numerical value for this is 0 to 50, which means that air quality is considered satisfactory and air pollution poses little or no risk. So the yellow one, no, is moderate, which means the numerical value for that is 51 to 100. So it means that air quality is acceptable. For some pollutants, there may be a moderate health concern for a very small number of people who are unusually sensitive to air pollution. So if kung naa kay mga respiratory problems or even asthma, maybe you are sensitive to this numerical value or to this quality index level sa health ninyo. So those are just example, no? So muna siya, no? This one, the meaning of an air quality index level. So red being the hazardous, which um, interpreted to 301 to 500 numerical value, which means that health warnings of emergency conditions, the entire population is more likely to be affected. So generally, kana nga area siguro very polluted. No, and dili na siya request for evacuation kay it would give or pose threats to the locality dira. So there are two types of infrared analyzers, no, which is used for the air quality, no, the spectrometer and the gas analyzer. So it is the spectrometer is a broad spectrum analyzer which consists in its simplest form of an infrared light source, a simple cell, and a light dispersion system, and an infrared detector. I don't know if this is present in the chemistry laboratory, but I don't know. Maybe it's not present. So for gas analyzer, it consists of an infrared light source, a sample, and a filter cell, and an infrared detector. So gas analyzer has an available portable na analyzer. So maybe this can be used outdoor sampling. So let me just give you a quick background that one of the most discriminating and satisfactory optical methods is the infrared analyzer. No, kaning mga infrared analyzer is kaning, for example, no, carbon monoxide, water vapor, ammonia, methane, nitrogen oxide, carbon dioxide, and even sulfur dioxide, no, absorb in wildly different spectral regions of the infrared. So this makes it possible to analyze a variety of mixture in one basic instrument. So, mao na siya, no? But since daghan kay siya although we can say it's unsay may discriminating ana niya nga daghan man siya ma-measure, it's of course the reliability. So maybe dili mao ang iyang pag-read sa kung let's say ang nitrogen oxide basin na anay mga anomalya, no, nga lahi na ang measurement niya. It's because more all-in-one na siya. So it makes it possible to analyze a variety of mixture, no, in one basic instrument. So of course, that's why this principle has led to the development of two types of infrared analyzers. Nananatay spectrometer, and we also have the gas analyzer. Okay, sa una mang good, murag napit na tayo all-in-one. It's because wala pa kayo na-develop atong technology. And all-in-one infrared analyzer. So that's why it has given a principle in which that it has to develop another type of or method of analyzing this specific kaning mga specific compounds, no? Specific pollutants in the air. So that's it. So now let's move on to the methods of measuring air particulates. So let's have particulate matter. So it consists of solids in the form of dust, fumes, or smoke, and of liquids in the form of mist or fog. So the sampling devices Okay, sorry for that. So the sampling devices involved are the gravitational, inertial, the diffusional, the gradient, and the sieving. So let us, kaning mga ginaturn nato nga mga aerosols, which is very common nowadays, no? Sometimes restricted to liquid particles. Kay, di ba ang aerosols are katong kuan kaning gikan na siya sa mga water or droplets kung sa COVID pa, droplets lang siya na ni-disperse na siya sa air. No mo na siya nga murag na-carry siya sa air and so on and so forth. So the term aerosol, sometimes restricted to liquid particles, is also used to describe any particles that are larger than single molecules but small enough to remain dispersed in a gas for a significant length of time. So kani siya, no, ang kaning mga aerosols are dagko dako ni siya compared siya sa uh, uban gases, no, but it's kuan small ni siya enough to remain dispersed in a gas. So meaning dili kay ni siya madala in a larger spectrum. So kung for example na ay COVID patient or COVID nga case sa isa ka lugar, for example, in Pugman, tapos silingan nimo, so dili na siya nga moabot nga sa lain nga mga zones ang aerosols. So it does not mean nga kung naay positive sa isa ka lugar, kailangan i-lockdown ng whole Pugman, no, kay tungod kay basin matakdan pud ang uban. So it's not that, no. Kay ang spectrum sa aerosols are just kanang mubo ra. So maybe ang lockdown is dito ra within sa area kung asa dapit. Maybe kana nga zone, no, but not the whole barangay itself. So that's it. So let's now move on to gravitational methods. So this is what we use gravitational, no. So these are based on use of gravity to collect particles usually larger than 1 micron. So basically katong naa sa inyong present sa inyong kuan na equipment for air quality, usually ang iyang gina-absorb from the air is of course through gravitational, in which nga mo absorb lang dito ang air dayon i-filter na dayon niya tong mga particulate matter nga iyahang na-receive. So this will now be discharged to the control valve and then the discharge to process a waste. So ang kato dayong mga dust, no, will now then be collected. No, so mao na siya nga ang mga heavy particles, syempre kay bugat man, dili maganda sila musaka, itong bugat mo sink gid sila. So that's for gravitational. For gradient methods, we have it involved scrubbers, filters, and filter media, electrostatic precipitation, and thermal precipitation. And there are two sampling equipments, no, under this gradient methods. We have the electrostatic precipitators and the thermal precipitators. So I cannot explain to you clearly by just giving you words, no, but you can just look for the video which I posted in the US step para makabalo mo unsaon ninyo pag-interpret ang kaning electrostatic precipitators and the thermal precipitators. So I posted a video guide for how you would interpret this gradient, no, on how this gradient method, no, is used in measuring the air quality. So the filters and the filter media are two of the ideal instruments for sampling particulate matter, no, because they meet a variety of specification and can be used with relatively inexpensive equipment. So these two are bigger instruments used for air quality, but kaning mga filters manggod and filter media are for small scale lang, and this one is for bigger scale na, like mga pag-filter sa industry nga kuan gamit ina nilang ginagamit electrostatic precipitators and thermal precipitators. So if you can read that, na dili ninyo ka ma-interpret, you can just click the video which I uploaded in the use tab so that you will be you will have an idea of what these precipitators are. So for electrostatic precipitators, no, it utilize a high potential produced by a special current transformer and a rectifier to produce 12,000 to 30,000 volts DC. So the high voltage is then conducted to an ionizing electrode, which charges the incoming particles in the atmosphere. And then charged particles are then attracted to an oppositely charged collecting tube and adhere to its surface. So this is basically a relationship between charged particles. So if positive would equally it would attract to negative ions or negative electrons, no, electrons. So which means na katurang mga negative ang ilahang ipang attract, and then katuda yung mga katuda yung mga mupilit sa ila ay that's the time na mupilit na dayon sa ilahang surface. Ang katong sa air ang component or ang composition sa air quality. So dito na dayon nila nga ma-measure kung unsa ka kuan ang air quality ana nga industry. So for thermal precipitators, no, these are based on the principle that dust particles are repelled by a hot body such as wire, but are attracted to a cold body such as a glass cover slip located at the proper distance from the hot body. So ang iyaha is, if for example, this is the heated wire, you can see that mora din siya ang principle daw kuno nga ang dust particles are repelled or dili siya mupilit sa katong init nga surface, but attracted siya sa katong cold body such as the glass or the cover slip. So for example, this is the glass, then the airflow, no, will go through this direction, and then those that are attracted to the cold body such as the glass will be would adhere to the cover slip itself for the glass, no. Mo na siya nga danha na day nimo siya ma-measure dayon ang isa ka kuan. So ang iyang process ana is, as the air is slowly drawn into the chamber, so manang airflow niya, so containing the elements, you know, sa mga this kind of pollutants or air na components, then the particles in the air are deposited on the collecting surface in the thin ribbon. So the modification of this method now have been developed so that the particles may be collected directly from the electron microscope examination. So that's why nga mo attract siya to the cover slip, kay para diretso ra din siya tan-awon sa microscope whether say mga deposition ang naa dito nga present. So the problem now is that the particle deposition in the heat exchanger reduces the heat transfer. Kay tungod kay naamagod ang glass, so medyo lisod ang pag-transfer sa heat. So that is one of the disadvantage of thermal precipitators. So another example we have is the sieving method. Another method we have is the sieving method, no? So it utilizes a porous barrier which has holes smaller than the suspended particles and is therefore particularly useful for collecting larger aerosols. So kaning apan lang sa sieving method is that it can only sieve certain sizes of air, dust, no? Certain particles. So if super small na siya, it would measure microns. Maybe there are sievers that can measure microns, then it's good. But katunag yung mga microns na super kuan na gid nga microns, tag-as na gid kayo nga micron like 1,000 microns medyo lisod na siya, or kuan ba siya 200 microns medyo lisod na siya. So the membrane filters are refinements of the system which are presently available with pore sizes with a size equivalent to a few tenths of millimicron. So the sieve method, the sieving method could only sieve about millimicron na siya, tenths micron. So naa siya sa 1 micron, 2 microns, no? So that's for sieving method. So these are particularly useful for liquid suspension as well as for aerosols, which is sieving method. So here is an example of modeling, no? Is a way of determining air quality. But kani siya, concentrations, estimate lang siya sa concentration sa kuan, overall niya nga dispersion. So, air dispersion modeling, no, a concentration of pollutants which people are exposed can be known or estimated by mathematical modeling. So, by mapping out certain environment or certain location, no, na ano yung mga ginabuhat nga, na siya exact measurement, not really estimation, estimation of measurement of what quality of air ang naadiha. So the legend tells itself nga kani nga mga certain nga mga colors, no, provides meaning in which the quality of air depends on the certain location kung unsa kataas ang pollutants niya. So maybe kaning green, the value niya, no, ang value, I can't see it clearly, but I hope you can interpret this because you can see it clearly here sa akong screen. So, the color signifies what do you call this? Signifies value of what the air quality measurement is. So, kana siya. So, yeah, I now, okay. So, this color no represents kaning mga blue, green, blue, kaning mga light, kaning mga sky blue color are areas, no, kung unsa na siya nga mga location sa map. And kaning gradient nga whole ani nga area, like for example kaning green nakabantay mo ani nga kanang layo mo kayang giaptan. So these are kaning quality of air nga say level niya, sa iyang total value sa quality sa air na disperse ana nga area. So even kaning mga naay blue nga area dani, kaning nga area dani blue kay camp something man ni camp sawi charon. So blue nga area dari lahi ni siya, area ra ni siya, and then kung unsa siya ka disperse asa siya taman, so that would give off nga kani di ay nga mga kuan nga mga areas dani having this type of kaning ina nakataas ang ilang quality sa air or ina nakamubo ang quality sa air. So muna siya, no, di kayo clear manggod. So that's it. So that's for the air quality, no, that we have. And let's just stop for that for air quality that lang sa tataman. So we'll have more on water quality and even soil quality on my next video, lecture video. So I hope that you all got my point on how I explained things here. So these are just methods on how you would use this in your future study if you would deal with air quality or meteorological factors such as temperature, evaporation, or rainfall or whatsoever. So these are just some guides, no, on what to use, on how to do such method, no, and techniques. So on my next video, I will be explaining to you the the water quality and the soil quality. So that would be all for now. Keep safe, everyone, and thank you so much. God bless.